Lesson 18.1, Task 1. All right, build understanding. X squared equals C. All right, so previously you learned to solve the quadratic equation x squared minus 4 equals 0 by factoring the difference of squares on the left side. Then you use the zero product property to solve it. You can also solve the equation by rewriting it as x squared equals 4 and using square roots. All right, so just a quick reminder. In the last couple lessons, you learned that x squared minus 4 equals 0 could be written, this is a difference of squares, something that you're going to see over and over, x plus 2 times x minus 2 equals 0. Remember, the middle terms cancel, that's why there's only a binomial here. So x times x is x squared, x times negative 2 is negative 2x, 2x and negative 2x cancel, and then 2 times negative 2 is negative 4. So this is factored form of this expression. So these two things are equivalent or equal. From here, we set each one equal to 0, and we solved. So for this quadratic equation, we got two solutions, x equals negative 2 and x equals 2. All right, so now it's saying that we can use this to rewrite it, x squared minus 4 equals 0. We can rewrite it as x squared equals 4. So what we would do is still solve it for x. So we're going to set x squared equal to 4, and then we're going to take the square root of both sides. But you have to remember, when you take the square root, you're going to have plus or minus 2. If you just put x equals 2, you're only going to have one solution. So if you solve it this way, you will get the same solution as when factoring. All right, so why is that? So square roots in quadratic equations. All right, definition of square root. A number b is a square root of a non-negative number a when b squared equals a. An example, 2 is the square root of 4 because 2 squared equals 4. Negative 2 is the square root of 4 because negative 2 squared is also 4. All right, so 2 and negative 2 are both the square root of 4. So in general, every positive number has two square roots, which are opposites. The symbol plus and minus square root are used to indicate a positive square root and its opposite. For example, square root of 4 equals 2, and negative square root of 4 equals negative 2. 0 has only one square root. The square root of 0 is just 0. Square roots of negative numbers do not exist in the real world. All right, so square roots of negative numbers produce imaginary numbers, which you will learn later. But right now, just know that square roots of negative numbers do not produce real numbers. All right, so what it means for a quadratic equation. The quadratic equation, x squared equals 4, is equivalent to the question, what numbers, when squared, are equal to 4? The answer to this question is, of course, 2 and negative 2, which are square roots of 4. The definition of square root allows you to rewrite the equation x squared equals 4 as x equals plus or minus the square root of 4. Recall that plus minus is read plus or minus. In general, given an equation of the form x squared equals a when a is non-negative, you can write x squared equals a as x equals plus or minus the square root of a. So let's back up for a second, and you can see that's what I did. I went from the square root to plus or minus 2. So that's going to be my plus or minus a. And if it's a perfect square, like in my example, there's no longer a square root. Like 4 is a perfect square. If a was 3, which is not a perfect square, you would just have plus or minus square root of 3. You would still have the plus or minus. So that's why the variables are there, because it shows that it works for all numbers. All right, square roots have two properties that are useful when solving quadratic equations. Each property is a direct consequence of a property of rational exponents. All right, so rational exponents and radicals kind of go together because square root, remember, equals something to the 1/2 power. So let's look and see what this says. So square roots in quadratic equations, multiplication property of square root. For a greater than or equal to 0 and b greater than or equal to 0. So when a and b are positive, the square root of a times b equals the square root of a times the square root of b. So that's showing that you can separate these under separate square roots. And that's just one property that is useful when solving these. Sometimes you'll have something and you need to pull out a perfect square, and that's why this would be useful. Quotient property of square roots. Remember, quotient means division. So for a greater than or equal to 0 and b greater than 0, b can't be 0 because you can't divide by 0, but it can be greater than 0. So for all positive numbers, a and b, the square root of a over b equals the square root of a divided by the square root of b. So very similar to the other property. Basically, it's saying you can separate into multiple square roots. All right, so let's look at some examples. The steps for solving the equation x squared equals 12 and x squared equals 16 over 9 are shown. State the reason for each step. All right, so the first example, x squared equals 12. So we're going to take the square root of both sides, and we do that. The square root cancels the square term and leaves x. And when we take the square root of 12, we get plus or minus the square root of 12. All right, and then we're going to have plus or minus. We can rewrite 12 as 4 times 3. And the reason we do that is because 4 is a perfect square. So when we look at these separately, like in the property we just looked at a minute ago, the square root of 4 becomes 2, and the square root of 3 is not a perfect square, so it just stays square root of 3. So all we're doing is rewriting this expression in a simpler form in each step. So square root, or x squared equals 16 over 9. All right, when I look at this, I'm looking at something squared. Well, 16 is 4 squared, and 9 is 3 squared. So when I look at this fraction, I see two perfect squares. So hopefully that you recognize that as well. So then you're going to take the square root of both sides. When I take the square root of something squared, it undoes it. And then I have plus or not minus the square root of the quotient, which means we can rewrite it as the square root of the numerator over the square root of the denominator. And since each one of these are perfect squares, you can reduce that as plus or minus. Square root of 16 is 4 and square root of 9 is 3. So we're just going to reduce that. All right, so let's look at a couple more here. All right, it says when the square root of 12 is written as 2 square roots of 3, it is said to be in simplest form because the radicand no longer contains any perfect square factors other than 1. What is the simplest form of square root of 18? All right, so let's do square root of 18. And all we're doing is looking at breaking it down, rewriting it in simplest form. We don't have an equation right now. We're just trying to simplify the square root of 18, just remembering our properties. So when I think of 18, I have 1 and 18, 2 and 9, 3 and 6. When I look at these, 9 is a perfect square. So I want to rewrite this as 2 and 9. So I'm going to rewrite this as square root of 9 times 2. And then when I do that, I can rewrite that as square root of 9 times square root of 2 using the previous property of multiplication. So the square root of 9 is 3, and the square root of 2 is still square root of 2. So the square root of 18 can be simplified into 3 square roots of 2, okay? And you can look at how that works, like if you wanted to look at that on a number line, you could see that the square root of 18 is about 4.24. And if you do 3 square roots of 2, so even though this looks drastically different than the square root of 18, you can see that those two are equal, they're equivalent. So if you were asked to put this on a number line, this number would go between 4 and 5 on a number line. All right, so it says show how to solve the equation x squared equals 27 over 25. So now we have an equation, x squared equals 27 over 25. So I'm going to take the square root of both sides. I'm going to have plus or minus here. So I'm going to have x equals plus or minus, and on the top I'm going to have square root of 27, and on the bottom square root of 25. Alright, so x equals plus or minus. On the bottom, square root of 25 is a perfect square, so it's going to be 5. Now 27 is a perfect cube, but we're looking for a perfect square. So again, we can break this down into square root of 9 times square root of 3. 3 times 9 is 27. So x equals plus or minus, the square root of 9 is 3, square root of 3 over 5. Now, if the denominator was not a perfect square, we would have to also rationalize the denominator. But for this one, that one is finished. So that's as far as we go. All right, that's all for task 1. If you have any questions, let me know.